Lesson 8.3, we are talking about accumulation functions in applied context. So continuing to look at the integral and how that applies with accumulation. The velocity of an object in motion is not only the rate that we integrate to get an amount. So right there, I know one thing that I saw several times in the note is the fact that, to get an amount, we integrate a rate. Okay, so just kind of get a rate, we integrate an amount. We have seen the accumulation or net change problems present us with a scenario where we are often asked to calculate the value of some quantity accumulated over time. That is one of our purposes of integrals, is accumulation over time. We can solve these problems using definite integrals. Now, part of what we're doing today is, and I guess that's more the second page, but how do we go back and forth between words and the problem? Like, what's the connection here? And then part of it is actually, writing out the problem and solving it. So let's look at example 1 here. You received a 10-week-old Basset Hound puppy for your birthday and discovered that he is gaining weight at this given rate of e to the 125 10,000th t pounds per week, where t is the puppy's age in weeks. At 10 weeks, the puppy initially weighed 14 pounds. What is the expected weight of your new puppy at the end of week 15? Okay. Thoughts? Go for it.
Can we do the y plus c to the x?
No, because it's not exponential growth. The ce to the, what is it, kt or whatever, is not, that would be for exponential growth. And let's hope this Basset Hound puppy isn't exponentially growing.
I was thinking about that. I was like, what if you plug in like a really big?
And that's, yeah, I mean, it works. It would work at the beginning, but then it would quickly get out of hand with exponential growth if you think about it. Because, it is growth. I agree. Okay. What do we know about this puppy to begin with?
14 pounds.
It's 14 pounds. So we have an initial condition, yes? Initially, this puppy weighs 14 pounds. I guess if I write too big, I'm not going to have room to solve this. And then what do we need to know past that? "10 weeks, puppy weighed 14 pounds. They're asking us for the weight of the puppy at the end of week 15.
T, would you do, if you said like 10 as 0?
Well, but we don't want to know just what it is. We want to accumulate here. And so, like, when we're thinking about this, we're doing the initial rate or weight plus what we accumulate. And what are we going to accumulate? We're going to accumulate from what time to what time?
11 weeks to 15.
I would have said 10 to 15.
Okay.
I think. Yes. Okay. My notes agree with 10. I wanted to double check. I see what you're saying.
Yeah.
Okay. But we know his weight at week 10. So we're going from week 10 to week 15. I see your point, though. That's a good, thing to think about. And what is the rate that we are accumulating this weight at? E to the 0.0125 t dt. And that's the problem you're doing, guys. Okay? Now, yeah, you can use the calculators if you want. And again, I've gone back and forth on these. This one would not, you could do this by hand, but with the decimal, I'd still end up having to use the calculator in E. I'd have to use the calculator anyways. So you're going to have 14 plus some integral value equals some total value. Now, you can put it all in on your calculator at once if you want. Be fancy there. Or you can get your integral and then add 14. What do we know? Okay. From week 10 to week 15, the puppy gains 5, almost 6 pounds. So then if the puppy weighed 14 originally, the puppy is now going to be at 19.847 if I go 3 decimal places. Or 846, I suppose. And that would be 19.847 pounds. I don't know why I just wrote that. You guys can see that okay? I'll change off the orange for the next one, but I try not to write an entire problem in orange, and I just did. Okay, so this is how integrals can help us with accumulation, because this is a rate at which the puppy is gaining weight. Okay, so by integrating that rate, we're able to find the total amount. Okay. I guess there is a calculator symbol here, isn't there? Was it this homework? Or is it the previous homework? Where, yep. So 9, 10, 11, 12 all say to use a calculator. I did 9 by hand. I did 10 by hand. I'm in the midst of doing 11. I'm like, ugh, yuck. And then I'm like, oh, there's a calculator symbol. Wish I would have realized that sooner. Okay, example 2. Electric monorail transport is slowing down at a, notice it's a rate of 2t plus 25 feet per second, where t is the time in seconds. By how many feet per second does the monorail slow down between t equals 1 and 5 seconds? What do we need to do? What does feet per second tell me?
Acceleration.
That's acceleration, yes? What are they asking me to find? By how many feet per second does the monorail slow down? So what are they asking me to find? Velocity. If you weren't already leaning towards it just because of the lesson we're in, does that give you a hint as to what to do? If you know acceleration and you're trying to find velocity, we're going to have to integrate the rate. So we're going to integrate 2t plus 25 dt. And what are the limits we're integrating? 1 to 5. Now this one technically does not have a calculator symbol. What's the integral of 2t? T squared plus the integral of 25? 25t, all evaluated from 1 to 5. So 5 squared plus 25 times 5 minus 1 squared plus 25 times 1. So I got 25 plus 125 minus 1 minus 25. And for me, I just said, oh, 25 minus 25 cancels, and I am at 124. 124 what? Feet per second. Okay. 3. number of liters of oil in a tank is changing at a rate, R of T is 0.26 T liters per minute, where T is time in minutes. Initially, the tank contained 14 liters of oil. Write an expression that can be used to find the amount of oil in the tank after 10 minutes. Got a thought?
Do you subtract that interval from the original?
What do you mean?
You have 14 minus the integral.
We're not going to subtract it, though.
We're gonna tack the 14 on front, then add it to the integral from 0 to 10 of the T.
Right. Initially, the tank contained 14 liters of oil, right?
Yeah.
That's your initial amount. Now, from there, what we're going to do, this rate appears to be positive because it's a 0.26 T. So we're going to assume that our oil, it just says it's changing at that rate, but it's going to be increasing. So we're going to add. And here's the deal. Even if the rate is decreasing and we're not realizing that, by adding this rate, if it is decreasing, it would become negative on its own. Or how should I say that? Does that make sense?
Yeah.
Like when you evaluate it, you would get a negative response. Okay. So, and this just says changing. I would like to think that, if it just says changing, I'm just going to add it. And now if it said leaking, something like that, then we might have to subtract. Okay? So, this is another situation where we are going to talk about initial plus the accumulated. Always watch for that initial. So initially this tank had 14 liters of oil in it, plus we have a rate. So we can't just plug in at the end. We're accumulating over this rate, which is 0.26 T dt. And what are my bounds? This says after 10 minutes, so we're going from 0 to 10. Okay, and that it'd be different if the tank, it contains, at 2 minutes it has that amount. Then we'd have a different scenario. Now, this one does just say write an expression. So do we have to go any farther? No. You can stop here. If you want to work it, it's not too hard of a problem to work, is it? And we've always got the calculator for that, too. I'm going to stop there unless you guys have a reason you want me to go on. Okay. 4A. Describe the meaning of each expression in context to the given scenario. So we got to pull our words out. We got to pull our English skills out today. The function W of T gives the number of water bottles produced by a manufacturer by time T in hours on any given day. Explain the meaning of the expression. So we have the integral from 4 to 8, W prime T dt. Keep in mind, we've been talking, if you want to get an amount, you integrate a rate. What is W prime of T? It's a derivative, which means it is a rate, yes? We're integrating a rate. Guesses on what this is going to be? So what does that mean, though? I mean, It depends on how you explain it past that point, I guess. I see what you're saying, that we're going to integrate a derivative, and so it's just going to be the function. But what is this in context of the problem?
The number of bottles produced from T equals whatever 4 hours marks to 8 hours, whatever, I don't know, like time
From 4 to 8 hours.
Just 4 to 8 hours.
Yeah, between the, I have it as between the, or during the 4th through 8th hours is how I happen to have it written. But it's the idea of from, in that time interval of hour 4 to hour 8. Okay. So, now if you think about it, and that's kind of, the function gives the number of water bottles produced, right? So it's the number of water bottles produced. That 4 and 8 say from the 4th hour to 8th hour. Okay, and that's, let's see. Yeah, I have written the number of water bottles produced by a manufacturer during the 4th through 8th hours. Okay, put something down. Number of water bottles produced during the 4th through 8th hours. Because they did give us a label and tell us that T is in hours, you should use hours there. Now, if they didn't tell us hours, then yeah, you might just say from T equal 4 to T equal 8, if we don't know what that is. But we do know what it is here. Okay. B, when you're ready. The amount of oil drained from your pickup truck is decreasing at a rate of R of T quarts per minute, where T is the time in minutes. What does the expression below mean? We have the expression of the integral from 3 to 4 of R of T dt is equal to negative 0.5. Three and 4 says
3 minutes, 4 minutes.
3 minutes, 4 minutes, right? So between the 3rd and 4th minute, right? What's that negative 0.5 represent?
Decreasing.
Okay. It says decreasing, right? It's decreasing at the rate. The fact that this is a negative indicates decreasing. And what is it that's decreasing? The oil draining, right? So how much oil drains? So a half quart, right? The negative would indicate it's decreasing as opposed to increasing. So between minutes 3 and 4, or between the 3rd and 4th minute, a half quart of oil drained from the truck. There you go. Between minutes 3 and 4, a half quart of oil drained from the truck. Just saying, there's not going to be much oil left in that truck for long. It's going to quickly be gone. Especially if you're losing a half quart of oil in 1 minute. There's a puddle under your truck. Okay. What about Kevin? What?
We're getting my car fixed.
Good.
We finally decided that.
Did it make it back to town? Or is it still
No,
up in
it's
Fort
still
Wayne?
Fort Wayne.
Okay, well. Okay. Kevin got a gift of $500 from his grandparents for graduation. He deposited the gift into his college savings account. Kevin's savings grows at a rate of RFT hundreds of dollars each month, where T is the month of the year. What does the expression below mean?
Well, whatever you say, it's going to be in hundreds of dollars. So.
Right? Which is demonstrated by the fact that.
Oh shoot! I didn't even say it said it on the paper. I just saw the 5.
Okay. Oh, you were just looking at. Okay, it has 500, and all of a sudden that 500 is expressed as a 5.
I didn't even see it said that in the problem.
Okay, but I mean that's a good connection. You've got to make the connection somewhere. But it does explicitly state that RFT is in hundreds of dollars. Which what's that mean about that 24? Then that is $2,400, right? What's 1 to 12?
1,200.
No.
Months.
That's
So basically, the course of a year is what it's.
Basically. All right. So, ultimately, what do we know about Kevin?
He's got a good grandparent.
Not the description I'm going with. Not the description that's going to earn you points for AP Calc.
They might laugh at it.
By the end of the
Year.
or since they used 1 to 12, I mean, I think years would be okay, but by the end of the 12th month, Kevin has $2,400 in his account. By the end of the 12th month, and I guess if you say by the end of the year, you want to be careful because if this is starting in, say, June, the end of the year was May. So you want to be careful to not say by the end of the year in 1 year if you want to go that route. Safer to probably just go in terms of 12th month. Okay? By the end of the 12th month, Kevin's account has $2,400 in it. Don't just say $24. That would get you in trouble.
If you had 24 to spend.
Okay. Moving along.
Are we going to finish the test today?
I don't know. I'm making that realization. We'll see.
We have like 1 page left.
We'll see. Okay. Table problems.
Yay.
Okay. Table problems are a thing. AP sees them as a thing. A city bus is accelerating from 0 to 18 seconds. The data for the acceleration, A of t, is recorded in the table below. If the velocity at t equals 0 is 6 feet per second, find the approximate velocity at t equals 18 using a trapezoidal sum. No, trapezoidal sums have not gone away, right?
Well, this one shouldn't be too bad. It's all the same.
Hey, at least we got that in our favor, right?
Yeah.
Okay. So, what do we have here? Bus is accelerating from 0 to 18 seconds. The data for the acceleration, notice that's what they give us here, right, is recorded in the table below. The velocity at t equals 0 is 6. So what is that saying? My brain correlates it to v of 0 is 6. Find the approximate velocity at t equals 18 using a trapezoidal sum. Keep in mind, velocity is the integral of acceleration, yes? So we're trying to find the integral. Trapezoidal sum is one of the ways we can find the area under a curve before we knew how to do an integral, right? Or when we didn't have a function. Because, you know, we started off doing rectangles under the curve, and then we eventually ended up with trapezoids because they're more accurate. So that's what we're looking at here. So in order to find v of 18, I'm going to do the trapezoidal sum here. And it just so happens, you know, they want to know the velocity at 18. What's the time go up to? 18. Okay, trapezoidal sum. Well, we're going to tweak it, but what's the area of a trapezoid? Okay, 1/2 of height times base plus base. So you can have a universal 1/2 out front. What was Ethan pointing out about the heights?
So let's say
My intervals are all 3 wide, yes? Since my intervals are all 3 wide, then that's my height. Now, because my intervals are all the same, when we go to do base 1 plus base 2, this is where we can use that shortcut. Yeah. We're going to use the first height and the last height once, and all the heights in between we're going to use twice. You remember me drawing the trapezoids out? And that left side does only get used once. But then once you get in between trapezoids, one side of a trapezoid is both a left and a right side of one and a left side of the other. So the first height is going to be a 1 plus 2 times 4, 2 times 6, 2 times 8, 2 times 7, 2 times 9, plus 10. That was our shortcut for trapezoidal. So I know 1/2 times 3 is going to be 3 halves. I got that in my brain. Whatever 1 plus 8 plus 12 plus 16 plus 14 plus 18 plus 10 is. All these numbers add up to be 79. I have a mistake in here. So, okay. What is 3 halves times 79? What is it? Okay. I don't have that value in my notes because I overlooked a minor detail. Just minor. Yeah. We had an initial velocity here, didn't we? I jumped right into trapezoidal. You guys followed me as good students do. You followed your teacher, and I don't know if anyone was out there thinking about it, but I wish you would have said something. So yes. Yeah. So what I really, in my notes, what I have is that this is going to be 6 plus all of those pieces, right? Like, in other words, if we think of the initial 6 plus the accumulation, so that's using the trapezoidal rule. So it should have been 6 plus. My bad. 124.5 watts feet per second, because this is velocity. I know, I'm bad about remembering the initial. I know I am. Don't follow my mistakes, okay? Watch for that initial, which is why I said it just like on the problem before. I said always remember, watch for that initial. I'm bad about it. Point proven. Okay. Technically, we have 2 more problems. The graph at the right shows the rate in gallons per hour at which stormwater is being pumped from an overflowing canal. Find the approximate number of gallons pumped from the canal in the 24-hour period. Thoughts?
I have something to say, but I don't think you're gonna want. It's not related to the problem.
No.
How do you have negative time with gallons? Like it continues on the left of zero. How do you?
Oh, the fact that the graph, like,
like I get initial, but like
that's a valid point. Or unless we talk about that negative time is before the 24-hour period. Is what, because like if this time zero here is the time at the beginning of this particular 24-hour period, that canal existed before that 24-hour period began. And obviously, we were storming or something, increasing, but so that's what I'm going to go with. I mean, I know, negative time. So I don't know, you get into these upper math courses and negative time does randomly exist sometimes. So this might be a situation where we can kind of say negative time exists, but it's just the time before the 24-hour period. Okay. So we are trying to find the approximate number of gallons pumped from the canal, right? So we're trying to find so many gallons of, what is this, stormwater? Well, generally speaking, how am I going to find the gallons of stormwater pumped from the canal over this 24-hour period? We're looking for an accumulation, yes. So if we're looking for an accumulation, we're going to be doing the integral, yes? Integral from 0 to 24. Officially, this graph is defined as R of t. So R of t dt. What do we know about R of t? We know this graph. Do we have a function? No. So how do we find that integral? We can. So the question was, do we have to do the trapezoidal sum? Wouldn't necessarily have to, we're going to do the trapezoidal sum. Wouldn't necessarily have to do the trapezoidal sum. We could talk like a right-Riemann sum or something where you're doing, which remember the Riemann sums is just doing the rectangles, right? So, we could do something like that where we're doing the rectangles, and that would work as well. Trapezoidal is going to make us a little bit more accurate. So I was going to go trapezoidal, but in other words, you're using one of these old school methods, right? So, one practice wasn't enough today. So we're going to do this trapezoidal sum. This is going to be the integral from 0 to 24 of R of t dt. And what do we know? We're doing a 1/2. What would be a good width of interval to use? 4, because it's kind of, we have every 4 marked, yes? So I'm going to do a distance of 4. Now, what do we need to know? What's the important part? We've got to find our various heights, and some of these are going to be estimates. Okay? We know this first height is 100. I'm going to go ahead and write these all down, and then I can write out my trapezoidal sum quicker. What's my next height? Pretty obvious, 125. in between 125 and 150. I would say a little bit past the halfway mark, maybe.
130.
See? Okay. I've written down 135 in my notes at the time, I guess. I would have maybe said closer to like 138, 140. I don't know. It's so hard to tell.
You know, we'll compromise. We'll do 138.
So, I don't know. My notes, if I look at my notes, I have the 135 number in there. Now, and here's the deal. 135, 140, are we wrong? No. Okay, what about this next number? Less than 135, more than 125, right? So if I want to go for a nice easy round number, I'm going to say 130. Next number is somewhere between 100 and 125. Yeah. See, in my notes I have written down 110, but I totally see the 115. Kind of like the last one, you know. Again, pick a number that you want to use. If I stick with my notes say 110. I'm not opposed to 115 at all, though. Okay, my next number is a value between 75 and 100. See, this one, I see more the 85. And then that last one is a number between 50 and 75. I'm going to go with 65. Again, these are estimates, yes? So if I write this out, the first number once, so there's a 100 plus 2 times 125 plus 2 times 135 plus 2 times 130 plus 2 times 110 plus 2 times 85 plus 65. I know half of 4 is 2. Did you guys add up these values, or did you do your own values? I have those values as totaling to be 1,335. And when I multiply that by 2, that is 2,670. This is the approximate number of gallons pumped from the canal. So 2,670 gallons. Okay. Obviously, if you use slightly different numbers, your final answer is slightly different, yes? So, understandably. Questions there? Okay. Marginal cost. Find the cost to produce 50 widgets. If the initial cost is $1,800 and C prime of X, so the rate, is given there, let X be the number of items of a widget produced. Let C of X be the cost to produce X widgets. C prime of X, we talked about this a long time ago. It's also called the marginal cost. It's been a bit, right? Which is the cost to produce one additional widget if currently X items are produced. That is, C prime of X is approximately, basically the difference in the cost, right? C of X plus 1 minus C of X. We want the cost to produce the first 50 widgets. Okay? Because we all know what a widget is, right? Good old math terminology. So if we want the cost to produce the first 50 widgets, what are we doing here? I wonder why she says the integral of something. Okay. We want the cost to produce 50 widgets, right? So the cost to produce X widgets, we're trying to find C of 50, if you will, but it's going to be C of 50.
1,800.
Well, and then what I was going to write here is minus the C of 0, which, what is C of 0? That is the 1,800. Yes, your initial cost is 1,800. So C of 0 is 1,800. Okay. Now, I'll put that value in later. In order to do this, in order to find that cost of the 50 widgets, we are doing the integral. And it's going to be the integral from 0 to 50 of the rate. So C prime of x dx, which we have a function for that, don't we? So we can go ahead and put that in. So we're doing the integral from 0 to 50 of 155 minus 30x plus x squared dx. Man, I totally did this one by hand too. As I noticed that. Although I say I did it by hand, but I did end up plugging in the final answer in the calculator. But so integral of 155 is 155x. Integral of 30x. Add 1 to the power, divide by it. So 15x squared plus 1/3 x cubed. Evaluated from 0 to 50. So I did that part by hand, but I ended up plugging in the calculator because it gets to be big numbers, right? But it's 155 times 50 minus 15 times 50 squared plus 1/3 times 50 cubed, right? So there's plugging in your 50, and this is where I went to the calculator. And then officially, that's the first part. And now we're plugging in 0. Is 0 going to matter? No, because all three terms would be zeros, aren't they? So yes, this is where I use the calculator. $11,916 and 2/3 basically. Okay. Now, keep in mind, what is that right there?
Cost to produce 50.
That is the cost of 50. But remember, we had that initial cost in there. And this is the cost to produce one additional widget. So essentially what we want to do is that C of 0 is 1,800, yes? Oops. So we're going to want to, for C of 50, it's going to be our 11,916 number plus the 1,800. So we end up with the cost to produce one extra widget plus the initial cost. And $13,716.67. I went to 2 decimal places because it is officially money. So this was the initial here, and this is the cost to produce one extra. Okay? You always find that cost to produce one extra there. Okay. I know. That's twice within a week we've done that. Or twice within 2 weeks, I guess. Okay. I'm trying to look ahead to decide what my plan is because I'm at that point in life where I just plan 2 days for every lesson, no matter what. And I have to decide what I want to do on the fly. Because there are 7 lessons. I was going to go ahead, I think, and do one more lesson before I do the quiz. I'm going to go ahead and do 8.4, which is area between 2 curves. So, we might. What do I want to do?
My life would be significantly easier if homework was not due.
As Connor's stressing about. Well, and here's what I can say. Is that I don't have to, regardless, I don't have to make the homework due tomorrow. What I could do is start into the next notes, but not have the homework due till Monday. And I will say, as I look through the next notes, I don't think we would do them in one day. So I don't think I would get myself in a situation where,
2 homeworks.
yeah, where we're back to homeworks. So we'll see. Honestly, we'll see how my night goes. I would like to think we could at least start a little bit into 8.4 tomorrow and then finish it Monday. But I need to sit down and look at it. Okay.
So we're looking at a quiz like late next week, maybe?